Now, after understanding the Bohr model and understanding how we explain the line spectra, mainly the hydrogen line spectra, let us understand its major drawbacks. The limitations, the first and the most important limitation about the Bohr model is that it only talked about the hydrogen and the hydrogen-like species. That means it only talked about hydrogen atom or hydrogen-like species, like we have helium plus, lithium 2 plus, beryllium 3 plus. What is common between these are that all of these are isoelectronic species. What is the meaning of the word isoelectronic? Iso means same, electronic means same electrons. All of these contains only one electron. So the Bohr was only able to explain how to and where to place the first electron. He was not knowing where to place the second electron. So that is why his model is a model basically failed to explain the structure of the multi-electronic atoms. It is only applicable to all those molecular atomic species in which we have only one electron, which are like helium plus, Li2 plus and Be3 plus. That is why in all the numericals which are based on the value formulas which are given by the Niels Bohr, we only use these molecular species, because in other actual molecular species which are having more than one electron, those formulas are not exactly applicable. So the first is he failed to explain the structure of the multi-electron atoms. Now the second important thing, which is also a great one of the most important limitations of the Bohr model, is that he failed to explain the fine line spectra. What is fine line spectra is? When these same spectral lines, or when the same line spectra is obtained by allowing the EM radiations which are coming out from any source to pass through electric and magnetic field, the spectra which we got was divided into further fine lines, and that is why that fine line spectra is called fine line spectra. I am repeating again. Those radiations which are coming out from any source and were falling on the photographic paper or plate, when were allowed to pass through the electric and the magnetic field, they get further divided into finer lines. Now those fine line spectra are called the fine line spectra, and he failed to explain why these lines are again splitting up into the fine lines. The reason is because that every suborbit is having further orbitals, orbit is having suborbits and then the orbitals, and the electronic transitions are taking place within these suborbits. So due to these transitions between the suborbits, we are getting what? The further fine lines. Now these fine line spectra are associated with two phenomena which are called Zeeman effect and Stark effect. Zeeman effect and Stark effect. Zeeman effect is splitting up of spectral lines in magnetic field is called Zeeman effect, whereas Stark effect is splitting up of spectral lines in electric field. So due to their further splitting into the fine lines, which is called fine line spectra, which are explained by the Zeeman and the Stark effect, the Bohr model was not able to explain why these fine line spectra. So that was the second most important limitation of the Bohr model. The third most important limitation of the Bohr model was that it failed to explain the formation of chemical bonds. How these atoms combine to form the bonds, how these bonds basically are formed, how they develop these ability to form bond. Basically, the reason is the ability of atoms to form bonds was not explained. Only the model talked about their structure, not about their ability to form the bonds. So these were the major limitations because of which we were forced to move further. Along with these limitations, two major event took place which actually changed the way we were thinking about the atomic structure, and these were the Heisenberg's uncertainty principles and de Broglie's dual behavior of matter particles. So these were the two basic principles which completely changed the way we were thinking about the atomic structure, and this is how we were moved to go to the from the classical mechanics to what the quantum mechanics, which is also called the quantum mechanical model of the atom.